Okay, so good morning everybody. We will continue our introduction to intelligent humanoid robotics. Still we are doing some Python programming. I will have to connect. Okay. So good morning everybody. We will start intelligent humanoid robotics. We'll continue with some more Python programming, in particular an introduction to Matplotlib and Numpy, as these are very important libraries that we'll be using throughout the course. But first, I just want to have a minute to see if I can connect the extra camera. Okay, let me see. Plus sources plus webcam. Capture device, create new Android phone. Okay. No. IP camera adapter. Okay, I think that's what I need. Okay, so this takes a little bit longer than I thought, so let's get started. So first library that we'll introduce is Numpy. It's a very efficient and powerful library for dealing with tabular data, with data stored in all sorts of arrays. So two-dimensional arrays, three-dimensional arrays, n-dimensional data, or integers, or other data types. So it's at the corners, at the heart of many scientific computing applications written in Python. Particular, it deals with matrices, which occur very often in scientific computation. So it supports the standard matrix operations, dot function for matrix multiplication, various linear algebra, functions such as inversion, inverse of a matrix, solve a system of linear equations, and various decomposition algorithms, so QR decomposition, SVD decomposition. And there's a third library, Seaboard, which is an add-on to Matplotlib. It allows you to generate more complex graphs. It allows you to make the graphs look a little bit more pretty. So we don't actually use Seaboard in this particular course, however. So it allows 2D graphs and charts, 3D scatter plots, pie charts, all sorts of drawings, and Seaboard is an extension of Matplotlib that allows even more powerful graphs and makes them look better. So first, let's go through an example with Matplotlib. With NumPy. So the standard way to use NumPy is to import it and then reassign the name to NP, which is the default that everybody uses in Python, in the Python programming community. In theory, you could use something else, but everybody uses this particular first line. Gone. So where is okay, and so now what we can do is once we have NumPy installed, we can create arrays of numbers. Common way to do that is to just say that you want to generate a NumPy array, and then let's generate a small matrix, 1.0, 1.5, 2.0. So in this case I pass it in as a list of lists. Four, 5, 5, 6, let's say. And then I can print that matrix, and it's printed out in, as you can see here, 1, 1, 5, 2, 3, 3.5, 4, 5, 5.5, 6. So this is the first row, second row, and third row of our matrix. I can also make it non-square, so I can add another row there. 6, 7, 7, 8. And now we have a matrix with 4 rows and 3 columns. Now the first thing operator that is quite useful in NumPy is a .t operator, which transposes the matrix. And I'm just going through the most important concepts. There's many other ways of constructing an array, of course. So you can read it in from a file, or you can generate a function to generate it all sorts of ways. So here a.t will print out the transpose of that matrix. So here's A. Here's a.t. So now I have 1, 1.5, 2, 3, 3.5, 4, 5, 5.5, 6, 7, 7.5, 8 along the columns rather than the rows. So let's have a look at a system of linear equations. That's usually called a regression problem. So I could just generate one. So let's see. Oh, and one other thing that is interesting is you can also look at the shape of the matrix. If you do some programming using NumPy, then you usually end up, if there is an error, then it's usually a mismatch of the number of rows or the columns, so the shape of the matrix cannot be coerced to match. So often it's useful to look at the actual shape of the matrix. That's done by using the shape property, and I can print that out. And this would be the property, the shape of the transposed matrix. So A is a matrix with 4 rows, 3 columns. A transposed is a matrix with 3 rows, 1, 2, 3, and 4 columns, 1, 2, 3, 4. So let's generate a 3 by 3 random matrix. And then another vector B which is just a 3 by 1 a column vector or a row vector. So if it's only either one row or one column, I just need to specify the length of it. So this is a one-dimensional vector, this is a two-dimensional matrix. If it's only one-dimensional, NumPy will actually do the change for you. So you don't need to worry specifically if it's a row or a column vector. So now let's say this is a system of linear equations. So we have three unknowns, x0, x1, and x2, and I multiply those by the matrix in order to get the value v. So I'll define a function in the next slide to print out that system. So I create an empty string, which will be my output. I don't actually want to print it here, I think. Let's call that function generate a linear system and convert it to a string. So I will have to generate the first row. So that would be in the column. So I want to generate a format so I want to generate a format string that prints out a y comma x with 2 decimal places and some width. And then I have to print out the actual value of the variable. So that should be times plus x, and I can do this as a format too. So x xx. Okay, if that's the end, then s plus equal be what? And then we return the string that we just generated. And then let's see how that looks like. So missed the new line character. Try that again. So I get, oh, so this should be D. F, B, Y. It's to be limited. And my new line character needs to go there. B, Y. And then this is the output that we get for our system of linear equation. Now this doesn't actually mean anything, I just generated it randomly, but it's 0.82 times x0 plus 0.075 times x1 plus 0.2 times x2 is equal to 0.69. 0.77 times x0 plus 0.42 x1 plus 0.13 times x2, 0.83, 0.9 x0 is 0.69 x1, 95 x2. So we have a system of linear equations with three unknowns, x0, x1, x2, and we have three equations. So if the values are not linearly dependent, then the determinant of this matrix would be not zero, and in this case we can actually solve it. So let's just do that. So there's a linkalg package module in NumPy, which deals with all the linear algebra algorithms that you may be familiar with. So it does, if you look at the help file that you get, these are all the functions that are defined. So eigenvalues, inversion of a matrix, Cholesky decomposition, matrix power, matrix multiplication, all sorts of functions. And here's also the solve function, SVD decomposition, which is an important decomposition that we'll use in areas like camera calibration for the linear distance transform algorithm. So it has some very powerful functions. In this case I just use a simple solver where I can pass in the A matrix and the B, and then it will, if the matrix, if the solution exists, then it will actually print out the solution or return the solution, otherwise it will generate an error. So here for this particular system that we had before, this would be the solution. X0 is 1.13, X2 is 0.27, and X0, X1, X2 is minus 1.27. So I can test that out. If I now want to verify the solution, then I need to calculate the output of the solution. So this would be A, the matrix A, matrix multiplied by the solution and then I can print B, which is the true solution, and the verified solution. Well, this is the problem, and this is the this is the solution that I found. So 6.92 times e minus 1, 6.92, 8.3, 8.3, 3.0, 3.3. So you can see that we did indeed find the exact solution to this particular problem. Now, a couple of comments. For two-dimensional arrays, actually NumPy allows a matrix class, so I can generate a matrix M . 1, 2, 3, 4, 5, 6. And for both NumPy arrays and matrices, I could also specify the type of operand. So if I want, in this case, I could just go, the data type is np.int. So now, if I want to do matrix multiplication, M1 times M2, if I write it like that, it will be matrix multiplication. So this is good. However, there's many functions that you cannot actually apply to the matrix class. So most people actually just stick with the standard array . And every time we do a matrix multiplication, it's very important that we use the dot function here. Which is basically calculating the dot product of the matrices with row vectors and column vectors. So just to show that, So I'll just define a 2 by 2 matrix. 1, 2, 3, 4. And then I generate another matrix, np.array. Some numbers, 5, 5, 2, 4, 3, 6, 7. So here are my two matrices, 1, 2, 3, 4, 5, 2, 6, 7. Now if I call A times B, then what do you think the output is? And I can call it, it's a legal operation, but what that will give me is the pairwise multiplication. So it will be 1 multiplied by 5 is 5, 2 multiplied by 2 is 4, 3 multiplied by 6 is 18, 4 multiplied by 7 is 28. That's one way to multiply these matrices, but it's not matrix multiplication. We're not dealing with them as matrices, we're dealing with them as two-dimensional arrays. If you want to get the matrix multiplication, then we have to call A dot B. And this now is the correct matrix multiplication. So 1 times 5 is 5, plus 2 times 2 is, 1 times 5 is 5, plus 2 times 6 is 12, is 17. 1 times 2 plus is 2, plus 2 times 7, 14, 16. 3 times 5 is 15, plus 4 times 6, 24, plus 16, 15. 3 times 5, 4 times 6, so to 39. And 3 times 2 is 6, plus 4 times 7 is 28, 34. So this now is the proper matrix multiplication. So one of the cool things about NumPy is that we have various ways to slice a NumPy array. So the general format is A, the matrix, and then the rows and columns that I want with a possible increment. So I don't have a big matrix right now, but I can say from row 0 to row 5, So row 0, but not including row 5 in increments of 2. And extract the column from -5 to -2 in current increments. Now this will give me a submatrix. This will just extract some elements from the matrix. Then I can do things like multiply each element by a constant, so multiply it by 10 plus 12 or something like that. So I can do all kinds of operations on these matrices and extract certain elements that I'm interested in. Shut this down. So we'll see more examples of this throughout the course. Now let's have some more fun.
Gust Online Lecturing Support said roll call, send a direct message to Gust Online Lecturing Support with secret number 7835. You have 5 minutes.
The most basic usage of the Matplotlib library is for doing two-dimensional plots. So in this case we need the PyPlot submodule of Matplotlib, and the common way to use it is to include it, to insert it as a PLT namespace for plotting. So very often we need to plot charts of some function, some data that we collected, and Matplotlib is very good for that. So let's generate some random data. Two rows and 20 columns. And random by default, if you look up the help, it'll tell you it'll generate a random number between 0 to 1 as a floating point number. So that's a little bit boring. So I multiply by 10. So I will get a number between 0 and 10, right? Because 0.99 multiplied by 10 will be 9.999. And then I'll add some offset to it. So I want the number to go not from 0 to 10, but from 2 to 12. So this is my data, and I can print it out. And I have two rows of this, so 4, 6, 4, and the second row 2, 3, 7, 9, 7, so on and so forth. And now I want to plot this data. Then in Matplotlib I have to generate a figure. There's several ways of doing it. I always write it like that just because I'm used to it. An important parameter there is you can specify the size of the figure, so you can make the drawing bigger or smaller. This would be 8 inches by 8 inches height and width. And then we need to generate an axis. Now the axis notation is a little bit strange. We'll see that in a second. For now, we just put 1, 1, 1 there, which means I want to have a chart, a graphic, that has one row, one column, and this is the first drawing, the one and only drawing. And then I can plot the data that I have. Now the first one, first row, any column, I want to plot it as a blue line, and I want the line width to be 2 or 3, so it's a little bit easier to see. The second one I want to plot as a dotted line. I think that's that. But instead of blue, I want to draw it in red. Or if you are very picky, you can set the specific color that you want as an RGB tuple. So I can say red, so I want very high red, let's say C0, a little bit of green, 50, and small blue value. So this would be mostly red and green, so it would be a cyan color, and line width is equal to 2 to 3, and label is equal to series 2. Series 1. And usually I can run this, but label. So then here's my graphic, right? This is the random points that we have as a red dotted line and a blue line, so on and so forth. Now for lecture slides I have to change it a little bit. For you this code is correct. I have to change things a little bit to generate the slides afterwards correctly. So then here's the chart. You can see we have a label for the different series, so I can say what it is. Okay, now so I forgot. I can also put a title on the graphic, so it says example Matplotlib chart. I can change the labels like here, you can see, because all the data is from 2 to 12, the Y label of this axis is, or the label on the Y axis here, ranges from 2 to 12. So it does auto scaling by default. And if I want to change that so that, for example, the label is not cut off, because you can greatly change the impact of a chart by just playing around with these. Hopefully I don't have to tell you that. For example, let's do this. Let's not multiply by 10. Multiply by 2 and add 15 to it. So now the data is completely random, so there's no relationship between it. But if I look at the data then, and I show you this particular chart, then I may say things like, oh, and you see, after the blue line went up here, the red line followed, and it's a huge increase as well. And then the blue line went down, and then the red line goes down as well. And the blue line goes down, red line follows afterwards. So it looks like there's a strong correlation between those two, and as if these changes are very dramatic, right? Huge up and down, huge up and down. But when you actually look at it, the range is only from 15 to 17. So if I plot it with different axes, then the impact of the chart is going to be very different. If you want to compare them, now I want a chart with one row and two columns. The first one shows it like we just did. The second one so now I have to increment this counter here. So this is the first subchart, this is the second subchart. So now the only thing I change here is I set the Y limits of the plot, and I say I want it to go from 0 to 17 rather than the auto scaling. Then you can see the impact of the chart is very different. AX2, AX2. So here are the two charts now, and you can see this one looks very dramatic, right? A change in blue will have a big impact on red. Here it looks just like a little bit of noise in the data. It looks much less dramatic in the changes that we actually have there. So depending on what you want people to do, if you want to tell them that there's a lot of danger, then you would show the chart on the left. If you wanted people to stay quiet, then you show them the chart on the right. So because visually humans are very good at interpreting natural scenes using their eyes. They believe very strongly into what they see with their eyes, and they have a very strong emotional response to all these different aspects of the chart. So it is actually important to be aware of these biases when you're dealing with information from the newspaper or the television or the politicians. By just changing a small thing in the chart, I can completely change the overall flavor of the information, the taste of the information as people will view it, even though the data is exactly the same. Those two curves that I'm plotting is exactly the same data. It's just a different way of visualizing it, different way of presenting it to people, depending on what I want them to do with my communication. So this is the Matplotlib library. There's also another set. If I don't want to plot something, then I can also do what's called a scatter plot. That one comes also is quite useful in many situations. So I generate random numbers, multiply them by 20, and I generate two rows of those. Then I generate a figure the same way as we did before, but now instead of plotting it, I can now plot it as points, the size of the points, 20 units, the color of the points is, let's generate a green, 20, 80, 40, or I can just put in a color like this too, by the way. I think I can just go yellow, and don't need a legend. Okay, that was not so smart. Yellow is a little bit hard to see. Let's take a darker yellow, so 80, 80, 20. And then here are the points, x coordinates and y coordinates of the points that we have. So I can scatter them If it's a three-dimensional plot, I can also change the size of the points or the color of the points based on some features. So whether they are in a machine learning problem, I could classify them with whether this is a cat or a dog or some other kind of labeling. So this is quite powerful, and the Seaboard library actually I think it changes it if I just can basically theme those charts a little bit. Let's see what that looks like. Yeah, so you can see now it has a grid on it and makes it look a little bit nicer. Okay, good. So that's a short introduction into NumPy and Matplotlib. We'll be using it a lot in the course. So I encourage you to familiarize yourself with it. How come my webcam is not working now? Weird. So my camera stopped working. I just try and reset the camera. Studio. Windows command processor. Okay, good. So now we will do a little exercise. First, you guys can try and solve that particular problem. 15 minutes, and then submit your solution to the NKUST direct messaging bot. So write a Python program that returns the second largest element in a list. Submit your solution to NKUST bot. And I'll give you 10 minutes to do that. So a program let me open that up. So we have a list, minus 2, 4, 6, 2, 8, 4, 3, let's say, and I want to implement a function second largest, which if I pass in a list, it will return not the maximum element. In this case here, that would be 8, right? But the second largest number. So for this particular list, the second largest number would be 5, so we should return 5. So see if you can solve that problem with your Python skills now. And I give you 10 minutes to finish that particular exercise. So if you have a solution, then submit it to NKUST online lecturing support.